The typical 8 inches per mile squared formula that they keep using is basically correct. The mistake they keep making is assuming that the numbers they come up with are referring to how much of a distant object should be hidden below the horizon, which is wrong. This math does not refer to your line of sight, so the fact that we can see a distant building or mountain from 200 miles away doesn't mean anything, and it does not disprove the globe. The proper, controlled way to obtain accurate measurements is to first establish a horizontal plane perpendicular to a plumb line from where you're making your observations. The easiest way to do this is with a theodolite, which is specifically designed to help geodetic surveyors measure the Earth's curvature. Most of these come with their own spirit level or auto level, which will help you aim your sights in a direction that would run perfectly parallel to the surface of the Earth, if it were flat. That is your horizontal plane. And simply by doing this, you'll see for yourself that the horizon does not come up to eye level as the flat earthers claim. And you'll see that distant buildings and ships do in fact drop below your horizontal plane as they get further away from you. This is proof of curvature. And if you refuse to follow these steps, then nothing you have to say about the shape of the Earth will ever matter because you're not actually measuring anything. Now, there are dozens of flat Earth videos where they claim to have interviewed surveyors who state that they've never had to deal with curvature. But since I happen to know a few surveyors who do deal with curvature, I was tempted to assume that these interviews were fake. However, after doing some research, I learned that many surveyors actually are pretty ignorant about the Earth's curvature. To understand why, you first need to be aware that there is a big difference between plane surveyors and geodetic surveyors. A plane surveyor can treat an area of a specified size as if it were a flat plane, usually an area of around 250 kilometers. Over these distances, the Earth's curvature is so subtle and gradual that it's almost inconsequential for most types of construction. To illustrate just how inconsequential it is, let's take a look at the construction of the Golden Gate Bridge. Its 2 towers are about 4,200 feet apart, and due to the curvature of the Earth, the tops of the towers are less than 2 inches wider apart than the bottoms of the towers. That's almost not even worth paying attention to. But when you start dealing with larger areas, you'll begin to accumulate some pretty considerable errors in your calculations if you don't begin taking this curvature into account. This is explicitly stated in just about every handbook and textbook dealing with surveying, radio broadcast engineering, aircraft and space vehicles, and numerous other fields. And you don't have to take any of this on faith, because you can actually go out and reproduce these measurements yourself. There are maps available for every state showing the locations of various benchmarks where measurements were taken to establish the geodetic datums and coordinate systems that the whole world uses. You can also look up the triangulation data for numerous bridges and other structures where curvature was taken into account. And in some cases, you can actually see where they compensated for it. So the curvature is out there, it is measurable, and anyone who says otherwise is either ignorant or a liar. And in case you haven't noticed by now, there are a lot of ignorant liars in the flat earth community.